Okay. Scenario analysis and probability distributions. This is where we introduce statistical analysis um, uh, into investments. So we're going to use this heavily during this chapter and the next chapter and throughout the rest of the semester. It hopefully have some understanding of statistics, and that will certainly help you. But if not, you're going to need to do a little bit of extra work so that you understand and how to do these calculations. So there's also a worked-in example where we do all the calculations involved on the next page. So scenario analysis is simply possible economic scenarios or outcomes. They'll have a likelihood or a probability and a holding period return. The probability distribution is the possible outcome with probabilities. The expected return is just the average of those returns, but we'll have to use the probabilities along with those expected returns to come up with that mean or average for the specific scenario. So variance is expected value of the squared deviation from the mean. And again, you need to look, if you're not familiar with this, you need to look at the calculations in the example that I work with regard to scenario analysis. So standard deviation is simply the square root of variance. Standard deviation represents a percentage change. So that's very important. We look probably the two most important values are the mean value and the standard deviation. We'll focus on those extensively. Spreadsheet 5.1, it's a scenario analysis for the stock market. We've got 4 scenarios over here, one through 4: severe recession, mild recession, normal growth, and boom. The probabilities respectively: 5% for severe recession, 25% for mild recession, 40% for normal growth, and 30% for boom. Holding period return for each of those: loss of 37%, loss of 11% in a mild recession, 14% growth in normal, 30% growth in a boom. So what we're going to do is we're going to multiply the probabilities times the holding period returns, add those up. We can calculate the mean return, or the average return. So and then we can calculate our deviations. This column is a deviation from the return. So we're going to use it to calculate the variance and standard deviation. So this is simply 37 minus our mean return of 10. So minus 47, 11 minus 10 minus 21, 14 minus 10 or 4, 30 minus 10 or 20. We square those and we sum them up. So this 40, square them, multiply them by the probabilities, and then sum them up, and we get the variance. Take the square root of that, and we get the standard deviation of 18.63, or 18.63%. So the calculations we're doing, we're typically assuming the returns are normally distributed. There are some flaws associated with this, but normal distribution is widely used in the calculation of investment returns and analysis because it's a lot simpler, a lot less complicated than other methods, and it's still reasonably accurate. Still gives us a lot of information. We can transfer normally distributed returns into a standard deviation score. So the standard deviation score R sub I is equal to the return minus the expected return multiplied or divided by the standard deviation. So, for example, if we go back to our previous page, this our for the first one, this would be negative 37 minus 10 divided by our standard deviation of 18.63, for example. That would give us our standard deviation score. So we could do that for each of the observations. We can get our original return given standardized normal return, or SRI. So we're just rearranging this equation. RI is equal to our expected return plus the standard deviation score multiplied by the standard deviation, and that would convert it back. That's all that would do. So normal distribution looks like this, and this is on normal distributions. Basically says that 68%. 68.2% of the observations are going to lie between one standard deviation on the downside of the mean and one standard deviation on the upside of the mean. So for our return here, that's a negative 10 and gain of 30%. And then 95% of our observations are going to lie between two standard deviations on the bottom side and then the upside as well. So in this case, it would be a loss of 30% and a gain of 50%. So 95% of our returns are going to lie in between these two parameters. So then three standard deviations is almost 100%. So I mentioned that the normal distribution has some issues, and that is because most investment distributions have what are called fat tails, and that means that there are observations that occur out on both ends that aren't captured by the normal distribution. So we're understating, by using the normal distribution, we're understating the risk. By how much? Not a whole lot. So but we'll talk about that a little more as we move forward. Normality over time. So when returns are over short time periods are normally distributed. Holding period returns of 1 month can be treated as normal. I assure you that people, investors and brokers and so forth treat holding period returns certainly up to a year as normal. They may not be completely accurate, but it is the chosen method of analysis because of the simplicity. It is important to use continuously compounded rates when normality plays a crucial role. Deviation from normality and value at risk. Kurtosis is a measure of the fatness of tails of a probability distribution. This is what I was talking about. It indicates a possibility of extreme outcomes. So it's not skew is a measure of asymmetry of a probability distribution. So it's skew is 1 to 1 would be returns to one side of the distribution. They're not symmetrical. But just take a step back, and value at risk is a measure of the downside probability. Typically, we would use a value at risk of approximately 5%, and I guess we'll talk about it a little more in a minute. But if we go and we look at our distribution here, a 5% value at risk is typically associated with a standard deviation of minus 1.65. So that's basically what we're talking about is all these observations out here. So the likelihood of an event out here is what we calculate with value at risk. So so we use time series returns all the time to do scenario analysis, and the information is widely available. The analysis is very easy to perform. We can do it on our calculator. We can do it on in Excel very simply. So it's again, it may not be perfect, but it provides us with a great deal of information. We can calculate variance and standard deviations, and those are when we calculate variance and standard deviations, we are making an assumption of normality. So, mentioned value at risk, so represents deviations from normality. So we can take the value of a portfolio and we can calculate the value at risk. We multiply it by the value at risk calculation and determine the amount of the portfolio at risk based on either 1 or 5%. So again, value at risk, measure of downside risk, worst loss given probability. We usually use 5%, sometimes 1%.